Okay, so this this is our series, and we want to find our interval convergence. Let us start with a ratio test. And so that would give me the n plus 1 term would be x to the what? That would be 2 times n plus 1, 2n plus 3, I believe. And the n plus 1 term there would be 3 to the n plus 1. I believe is what we get. Yeah, 2. If I plug in n plus 1 there, 2n plus 2 plus a 1. Yeah, so it's 2n plus 3. With me? Then we're going to divide by a sub n, but that just means multiply by the reciprocal. So let's just go to that. The reciprocal of a sub n. All right, and so a little splitting out of terms here, that would be x to the 2n times x cubed. That would be 3 to the n times 3 to the first. And then over here, oops, x to the 2n times x to the first. Yeah, we get some cancellation if we split it up like all that. The x to the 2n's, 3 to the n's cancel. And what's left over? Well, that would be x squared there, wouldn't it? For the x's. Yeah, so I'll wind up with all the n's cancel. I believe so. Yeah, as n goes to infinity, we don't have any n's to run to infinity, so the limit of that is just the absolute value of x squared over 3. And it being x squared, the absolute value, we're talking real numbers, and so the absolute value doesn't really add anything to, since we're squaring the x. Yeah, but by ratio test, we want that less than 1 for it to be convergent. And so that would, if I multiply both sides by 3, give me x squared is less than 3. And we looked at those. Those are a little different than just having like an absolute value of x. Remember what those were? The endpoints are? Square root of 3 and negative square root of 3. So yeah, the x will be between the square root of 3 and positive square root of 3. Negative square root of 3 and positive square root of 3. So we know it's convergent for all of that, but it doesn't tell me about the endpoints because that's where this would equal 1, and ratio test doesn't tell you anything when it equals 1, and so you have to check those independently. At the endpoints is where that would equal 1. So check, the second part of this is check the endpoints just to get everything checked. So we're going to check the square root of 3. And so that just means go all the way back here and put in x as the square root of 3. Just substitute it straight up for that. See what series that gives you. It's gonna work out pretty nicely here. That's again, let's split that up. Square root of 3 to the 2n plus 1 is the square root of 3 to the 2n. Square root of 3 to the 1. What's this?
That's just 3 and 3.
That's going to be 3 to the n, yeah. And so that's going to cancel nicely out. That's square root of 3. I mean, this 3 to the n's are going to cancel out. and just give me the series of square root of 3's. That series right there, which is divergent or convergent?
Convergent.
Well, we're adding up square root of 3, square root of 3. Oh, yeah, so we're adding infinitely many square root of 3's, square root of 3 plus square root of 3 plus square root of 3, infinitely times. And so, yeah, that's definitely divergent. What test would you?
That's for divergence.
Yeah, test for divergence would. The limit, yeah, if we look at the limit of the a sub n's, it's square root of 3, but that's not good for a series. If that's not 0, it's divergent by test for divergence. I think a similar thing happens on the negative square root of 3, right? We plug in negative square root of 3 for the x. Yeah, because, well, you get the same exact thing. Your negative square, well, you get the negative square root of 3, but that's still 3 to the n, isn't it? Because you're squaring, you're basically saying that, right? You're squaring the negative square root of 3, which is still 3, and then you still get 3 to the n. So yeah, you get this negative square root of 3 instead of square root of 3, but that's still divergent by test for divergence. So neither one of the endpoints work, and so that turns out to be the interval of convergence. Negative square root of 3, positive square root of 3, however you want to write it. And then that makes our radius of convergence r, well, it'd be square root of 3, wouldn't it? Because that is just the radius, I guess. The distance from the midpoint is how we would find it, but that's obviously going to be square root of 3 there. All right, so just another example of what can happen there, different types. Now, there are a couple of other things that can happen where we don't get, actually get maybe something nicer, you might say, happens with this limit from the ratio test. Okay, so let's look at an example of each of those. There's a couple things I'm talking about here. All right, so this one's going to be series is -1 to the n, x to the 2n, over 2 to the 2n, n factorial squared. Okay. Got a lot going on there. Let's see what happens. So interval convergence, radius convergence. So again, start with your ratio test. And the good news on this one is we are talking absolute value, and so the alternating signs part, we can take that out. But the rest of it, so we'd have n plus 1 term, that would be x to the 2n plus 2. N plus 1 term there would be also 2 to the 2n plus 2. And then n plus 1 factorial squared. Still a lot going on. And then divided by a sub n just means the reciprocal. We don't have to do the alternating signs part. The 2 to the 2n, n factorial squared would be on top then, and then x to the 2n, so denominator. Okay, so split some things out. X to the 2n times x squared, 2 to the 2n, 2 squared. N factorial squared, well, let's split that up as, n plus 1 factorial we can write as n plus 1 times n factorial. And so what we'll have there is since I'm squaring it, I'll have n plus 1 squared and n factorial squared, right? Over there. And then 2 to the 2n, n factorial squared. X to the 2n, I don't think we have to break that down any place. All right, so the x to the 2n's will cancel. 2 to the 2n's will cancel. N factorial squareds will cancel. And so now let's split out the n's and the x's separately here. What have we got here? Nothing on top as far as the n's go. And then on the bottom we've got 4 n plus 1 squared. So we put forward 1. The next squared's over here. Yeah. Well, long story short here, n goes to infinity, this goes to 0, doesn't it? And 0 times x squared is still going to be 0. So yeah, we haven't talked about one yet where that happens. So yeah, this limit comes out to be just 0. Well, ratio test, where's that less than 1? It's everywhere. 0 is less than 1 all the time. That's always true. Well, in the context of this problem, what does that mean? Well, what we're looking for is the x values that make this ratio less than 1. If it's always true, doesn't that mean x can be anything? Yeah, x can be any real number. Or to put it another way, x can be anything from negative infinity to positive infinity, right? That's our interval of convergence. Yeah, so if our ratio here comes out to be 0, the interval of convergence is negative infinity to positive infinity, because it's always true. And the radius of convergence, well, it's infinitely large, so it's an infinitely large radius of convergence as well. Now, let's look at another one. How about n factorial x minus 2 to the n? Well, the limit as n goes to infinity on that of a sub n plus 1 over a sub n, what would that be? Well, it'd be n plus 1 factorial times x minus 2 to the n plus 1. And so, since we don't have denominators here on this one, let's just go ahead and divide by a sub n, which is that. Well, I think we can see some cancellation is going to happen there if we split some things out. N plus 1 factorial, again, is n plus 1 times n factorial. And then x minus 2 to the n times x minus 2 to the 1. Split that up. And then do some canceling. X minus 2 to the n's cancel, and n factorials cancel. So that leaves me the limit as n goes to infinity of n plus 1 times x minus 2 times 2. Well, kind of the reverse happens here, because as n goes to infinity, that's infinity plus 1. It's infinity. So we have infinity times whatever here. That's infinity. So the limit is infinity, which, when is that less than 1? Maybe never. However, there is one exception, so it's almost never. Because if you plug in x to be 2, here's the series we get. N factorial times 0 to the n. Well, that's just 0 plus 0 plus 0. It's always 0, and so that does converge. I mean, kind of, obviously, that converges. So there is one value for this, which this converges. It is at x equals 2. Okay, so the interval of convergence, well, it's kind of a misnomer there because it's just one value. Usually they may just write it the set braces there. It's one value where it converges. It's not really an interval at all. It's just one value. Now the radius of convergence there, well, doesn't have any radius whatsoever. The radius, therefore, is 0. So yeah, this is kind of compare and contrast here. If you get infinity for your limit, your radius of convergence is 0. If you get 0 for your limit, your radius of convergence is infinity because of the way this is structured. So anyway, those are two special cases that might occur. All right.